Push that rock with some math. Let's talk about polynomials and end behavior. Here's 3 examples of polynomials. And we can see that on the ends of the graph, this one is going down. We call this decreasing, but going that way, it's actually increasing. It's coming up, but we say it's falling on the left, falling on the right. Here's another polynomial, rising on the right, falling on the left. There's a linear, rising on the right. Its slope must be positive. So the behavior of the y values of the polynomial as x goes to infinity is called the right-end behavior. The behavior of the y values as x goes to negative infinity is the left-end behavior. These polynomials have same end behavior. The right and the left are both, the y values are going to positive infinity. But down here on the right and the left, the y values are both going to negative infinity. So they're both going to negative, the y values are both going to negative infinity, both y values are going to positive infinity, so we say same end behavior. Sometimes there's opposite end behavior. If the y values on one side, on one end, are going to positive infinity, but the y values on the other are going to negative infinity, we call it opposite end behavior. So both of these have opposite end behavior. So lines are first degree polynomials, and a positively sloped line looks like this. A negatively sloped line looks like this. Notice that it has opposite end behavior all the time. All lines other than flat lines, all lines that are non-zero slope have opposite end behavior. And it's first degree. First degree have opposite end behavior. Parabolas, though, they have the same end behavior. See, they're always the same end behavior. And so if they're the same end behavior, but they have second degree, I wonder if there's a connection there. So when it was first degree, it was when odd degree, it was opposite behavior. Here it's even degree and it's the same behavior. I wonder if that's a connection. Here's a cubic, here are some cubics. And that means that the highest power is 3. So it's a third degree. Again, that's an odd number. And look, opposite behavior all the time. All of them have opposite end behavior. So, wonder if there's a pattern. Here's Cortic. Cortic would look like this. And the highest power would be to the 4th power. You know, some of these could be zeros. If all of these coefficients out here are zeros, we just have some number x to the 4th that's a quartic. It'll look like this. If you have a lot of coefficients, it might look more like this, or it might look like this, where it's falling on the right. Falling on the right. It can look like this. It can look almost like a parabola. It's not one, but it can look almost like one, falling on the right. Or it could be rising. But notice, whether it's rising on the right or falling on the right, it has same end behavior, and it's even degree. So a question you might ask is there a connection? When the degree is even, is it always going to be the same behavior on the ends? And when it's odd, when it's an odd degree, is it always going to be opposite? You can investigate. Tell me what you think. Math Made Simple, some math.